Okay, so let's finish up Chapter 8, Section 8.3, by continuing to talk about estimating a population mean with a confidence interval. This would have been our lesson for Thursday, except we have a lovely snow day. This is a very short conclusion to the chapter, and there are two goals. The first goal is to describe how the margin of error of a confidence interval changes with the sample size and with the level of confidence. We've already talked about this a little bit, okay? Basically, as our sample size increases, the confidence interval narrows. So this really is a review. Okay, so as my sample size gets bigger, my confidence interval becomes more accurate, meaning that it doesn't need to be as wide, it can be smaller. As my sample size is small, my confidence interval is going to get big. And then, as my level of confidence, C, increases, the opposite happens. The confidence interval widens. Again, this is a review. Why is this true? Well, just imagine if you want to be really confident, you're going to provide a wider range of possible values. It's like that little cartoon I showed you. If I predict the temperature is going to be between negative 20 degrees and 100 degrees, I'm more confident that I'll be correct than if I predict that the temperature will be between 30 and 35 degrees. So as you're more confident, your interval will widen. The other thing I want to talk about today is the concept of a robust procedure. Okay, so I don't know why the slide turned out funny here, but you have these notes at home. Okay, we already know that our confidence level for a one sample t interval from mu is exactly correct when the population distribution is exactly normal. Unfortunately, it's very rare ever to get an exactly normal population distribution. It doesn't really happen often. So in real life, when we use our t procedures, how effective they are depends on how normal or non-normal our population data are. And this leads us to the definition of robust. A inference procedure is called robust if the probability calculations involved remain fairly accurate when a condition for using the procedure is violated. The good news is T procedures are generally robust. Okay. The only time my T procedures are not robust is when we have outliers or very skewed data. And remember, this all has to do with the population. Okay. So generally, our T procedure will still give us a very, very accurate confidence interval as long as we don't have outliers and as long as our data aren't very skewed. So here is how we can use our T procedures wisely. This harkens back to the example from my previous video. In that example, we didn't know the shape of the population distribution, but we also only had 20 pieces of data, so we had to examine the sample data to take a look at what the shape was. And so here are the guidelines for looking at the shape. The first guideline is our sample size is smaller than 15. Now in that case, with such a small sample size, we need to make sure our sample data appear roughly normal, so very symmetric. single peak, absolutely no outliers. We are allowed to use t-procedures in that case. If we see any clear skewness or if any outliers are present, we cannot use the t-procedure. So when we have a very small sample size, smaller than 15, we need to make sure our data are very symmetric, roughly normal looking, to be able to use t-procedures. The middle case, okay, if we have sample size of at least 15, and when they say at least 15, what they really mean here, okay, is between 15 and 30. So we already know what happens when we have 30. So if our sample size is bigger than 15 but smaller than 30, we can use t-procedures except in the presence of outliers or strong skewness. So in this case, when we look at the graph of the sample data, it can be a little skewed. It just can't be extremely skewed, and there should not be any outliers. And then we know in large samples, this is always true. As long as our sample size is sufficiently large, meaning greater than or equal to 30, we can use t-procedures, even if our data are very, very skewed, okay? As long as our sample is large. And again, I mentioned this before, but the key is, especially on any assessment or the AP exam, make sure you plot the sample data to justify your reasoning. Okay? You can't just say, oh, well, I looked at the plot on my calculator and I can assume it's normal or it's sufficiently close to normal. You must provide visual evidence for the reader, and that will come in the case of plotting your sample data, box plot, dot plot, something like that. So again, here's a summary. T-procedures are robust, meaning they're still effective. When the population is non-normal, especially when our sample sizes are bigger, they are not robust against outliers or very strong skew. And here's the corresponding homework for this particular assignment, 67 and 73, which are kind of like 4-step process problems, and then 75 to 78 are multiple choice. Email me your questions, and I will answer them in this format over the course of the weekend. Okay, I won't answer every single homework problem or anything like that, but I'll answer a few here and there. So feel free to email me and ask me any questions you have. Enjoy your snow days, and thank you so much.